Okay, so different useful lives. You can't compare option A and option B if they cover a different number of years. And the reason why you can't is because, remember, the time value of money means that money in the future has a different value than money today. And so if one of the alternatives is going to last for 6 years and another one of them is going to last for 8 years, then those years in the future that the other alternative is earning money, those years aren't accounted for in the perspective of the first alternative. So we have to have some way of making it the same study period. And so there are 3 methods that I've introduced so far that allow you to overcome the problem of different study periods. And one is you just repeat the cycle, and that's the least common multiple approach, which relies on the repeatability assumption. There was the contract services approach, where what you do is you extend the shorter option. If option A was the one that was too short, you make it longer by renting equipment for the remainder of the study period to bring it up to the same number of years of the longer alternative. And then the third option was you take the alternative that's too long and you make it shorter by selling the equipment early. Early termination is basically that you go onto the secondary market and you sell the equipment while it still has some useful life, and that lump sum resale value at the last year of the cash flow diagram is how you account for the different useful life. So these 3 methods were overcoming the problem of different useful lives. In future worth analysis, we can use those same techniques, but in each of these, what we were trying to do is we were trying to find out how much is the equivalent present value of all of these future amounts. There are some cases where instead of knowing a lump sum present value, we instead would prefer to know the future value as a lump sum. We still have a lot of the same rules when we do future worth analysis. You have to have equal service periods, meaning that the same number of years between option A and option B. And the places that we would use future worth analysis instead of present worth analysis would be really large projects that take many years to construct, where perhaps a contractor or an investment company is laying out the initial funding to construct a project, and then at the end of the project's construction period, it is sold to the buyer for a single lump sum. And so that's one example of where you maybe would need to know future worth analysis because you've built a house or a building or maybe a business. You've done some things over time, and now as you turn it over to another party, you're trying to find out what is a fair purchase price as a lump sum in that future date. So that's an example of where you would maybe have cause to use future worth analysis. So decision criteria is how you know which alternative to choose. It's the rule that you apply to choose one thing versus the other. And so in future worth analysis, the decision criteria is you're compounding amounts to the future at the MAR, and then of the options that are non-negative, you'd choose the highest value as the most profitable alternative, and so that's the one you'd select as the one with the highest non-negative future worth. All right, so today's in-class exercise, we're going to take the case of a shipping channel that needs to be rebuilt. And there's 2 options that we're going to compare, both at an interest rate of 7%. We're going to use this one, we're going to do Microsoft Excel. So if you've got your computer, go ahead and fire it up. We're going to use Excel today. Option A, you can see, is more of a long-term solution. It's going to take 3 years of payments during the construction process, but then after the item is built, it'll generate a certain amount of revenue over a 9-year period. Option B, by contrast, is a short-term fix that's going to have to be done several times to get to the same 9-year study period. So it says here in the problem statement that we're going to use the least common multiple approach. So we're going to use LCM in order to solve this. So just that you get some practice with the LCM setup, let's first of all start a spreadsheet, and let me show you the columns that you're going to need to put in, and then I'll pause for a moment so that you can fill in the columns. All right, so first of all, interest rate here we know is 7%. All right, so you're going to have year. And does anybody remember when we did the future worth analysis, what was the deal with the secondary time column? Why did we have that? Where it was like years until some time in the future. Does anybody remember? What was the purpose?
You had to compound that amount that many years into the future.
That's right, because you're compounding to the future. So for example, when you're at year 0, you don't want to compound the amounts 0 years into the future. The amount that's at time 0, if we just briefly go back here, you can see this $220 million at time 0, we want to compound it 9 years to the future. We don't want to compound it 0 years to the future. So there's going to be a secondary time column we're going to call years until year 9. All right. And then there's going to be amount, future value of amount, and both of those are going to be for option A. And then over here, option B will have amount and future value of amount. And we can do fancy things like, let me just show you, we can merge these cells to make it more clear. It's got a wrap. No, merge, yeah, merge. These are applying to this column. All right, so years until year 9 starts at 9. And so this is a 9-year time frame. We want it to count all the way 0 through 9 on this column, and then equals 9 minus the year for the reverse time column. All right, so what you need to do is fill in the rest of this table just up to the amounts. And that seems negligible, but remember what we're having to do is the repeatability assumption. So option A you can just enter directly, but option B you need to repeat it 3 times so that it covers the 9-year study period. All right, so let me pause for a moment. Basically what I want you to do is fill in the amount column for both option A and option B. Translate the cash flow diagram into the cash flow table. Okay, I'm going to start filling in the values here. You can follow along if you like, or continue working.
So the only thing I don't understand, why did you do the 190?
Up on the whiteboard, I've drawn the repeated cash flow diagram for option B. And I want to draw your attention to a couple of common mistakes that people make. So I don't want you to make those mistakes. Sometimes people would instead of buying the item at year 3, sometimes they buy it at year 4. But the problem is if you buy it at year 4, then you'd have a gap in the revenue. So you buy it in year 4, and then you wouldn't get your next revenue until year 5. That effectively means that you had a year where the item wasn't in use between 3 and 4. So you need to be careful on when you actually purchase the item again. You need to purchase it so that there is uninterrupted service through the entirety of the cash flow diagram. So that means we need to do it at year 3 and year 6. So that's one of the common mistakes that I sometimes see people make. And then the other is sometimes they'll buy it again at year 9. Why wouldn't you buy it at year 9?
Because you're done with it?
Yeah, because the study period is finished. If you bought it again at year 9, then essentially what you're doing is you're entitling yourself to additional revenue in the future beyond the study period. So we don't need to buy it again in year 9. We just need to buy it in year 6 so that it's usable through the 9th year. Okay, so is everybody with me on this cash flow diagram? Everybody understand why the amounts are these amounts? Any questions before we continue? Okay, so the FV function equals FV parentheses. Okay, it wants to know the interest rate, so we'll click on the interest rate and anchor the reference. Remember, you can do that either by pressing the F4 button or by putting in the dollar signs manually in front of the letter and the number. Okay, so anchor the reference to the interest rate, comma, number of periods. So it's asking how many periods is the amount going to be compounded into the future. And you may be tempted to click on 0, but that would be a mistake, because what we really want to do is we want to take this $220 million 9 years into the future. So that's why we click on this reverse time column cell. Now, parentheses, comma, payment. If we put the amount in the payment field, it's going to think that there's 9 payments of $220 million, but there's not. It's just we're treating this 220 in this cell as a single isolated present value that needs to be compounded into the future. So we're going to skip over the payment field with another comma, and then it's the minus of the amount in the present value cell, so that when you close parentheses and enter, it's going to take that $220 million 9 years in the future, and that turns out to be a cost of $404 million at year 9. So now we can drag that equation down, and it will calculate the future value of each of these individual amounts. And one of the indicators that things are working the way it should is that the amount that's already at year 9 doesn't change. So we know it should be the same because it's already in the future. This $55 million at year 9. Okay, so now we can total things up with the sum function, and you sum all of that range just by clicking at the top and dragging down through it. All right, so $659 million is the lump sum future value of option A. So like if you were going to do all this work and then get paid 9 years in the future, you'd want to collect $659 million for an interest rate of 7%, for there to be equilibrium between what you had spent and then the amount that you were collecting in the future. Same thing with this option B. We're going to use the FV function, so equals FV parentheses. Okay, click on the rate and either put in the dollar signs manually or press the F4 button. Comma, number of periods, NPER. We need to click on this years until year 9. Double comma to skip over the payment field, and then it's the negative of the amount, and that goes into the present value area. Close parentheses. Okay, and so we can apply that downward. You can either click and drag or just double click in that green thicker box at the lower right. And then again, we do the sum function. All right, so have we answered the question? Not all the way. We've done the analysis, but we haven't actually answered the question. And if I like to tell you mistakes I've seen in the past so that you can avoid the mistakes that other students have made. And sometimes the mistake is that you don't actually say the conclusion. So down here at the bottom, determine which is better. You have to state, you have to answer the question. So we would say, if this project is a must-do, then option B is best since it has the lowest future worth of cost. In other words, option B is cheaper, thus better. Assuming that they both perform equally well, we're kind of already accounting for how good the solutions are because they generate different amounts of revenue. Option A generates more revenue each year, but option B is still superior from an economic standpoint because it has the lowest overall cost when everything is taken to the future. So the point is, we've done the analysis, and then we've answered the question while citing the decision criteria. And the decision criteria, remember, for future worth analysis is choose the alternative that, if it's non-negative, has the highest present worth. And in this case, this is kind of like a public works project where we have to do the project. It's not an option of letting the channel silt up. So the project has to be done, and so there the decision criteria is you choose the alternative that's the lowest cost. And $607 million of cost is better than $659 million worth of cost. Any questions about this one? Okay, the other problem we're looking at today, let's read through this. Your uncle wants to make an investment and is interested in the total value of the investment at the end of an 11-year time frame. His minimum attractive rate of return is 4.5%. Okay, so there's two different alternatives that are being considered. Option A, he pays $250,000 today and then receives $33,000 each year for 11 years. Option B will return $25,000 each year for 11 years, but the seller hasn't yet quoted a price. So we don't know what the cost at time 0 is. So first things first, just to help you visualize this problem, I suggest draw the cash flow diagrams for both options, summarizing what is known and what is unknown. Okay, let me pause for a second for you to do that. To sketch out the cash flow diagram that shows option A versus option B, and then we'll go through the future worth analysis together using Excel. All right, so what's the future value of option A? Let's start a new sheet for this problem, and I'll paste the question. All right, so we're going to do future worth analysis again. So up at the top, we want to define the interest rate as 4.5%. And we can copy these column titles from the other page, so we don't have to type those in again. Year, years until, and so on. I'll just need to maybe also have it paste the width. There we go. So it's not years until year 9, it's going to be years until year 11 for this one. So we're having 0 through 11 on the years. And then 11 through 0 on the reverse time column. And then we have the amounts. For option A, we know that he would pay $250,000 today. And let me format all of these as currency right here at the beginning, just so that I can see more specifically if the comma is in the right place, because I'm typing in lots of zeros. So that comma lets me see that I got it right. And $33,000 each year through the remainder of the study period. Okay, and then we're going to find the total FV down here at the bottom. So then the FV of the amount, we'll do that in a minute. Now, okay, so what's the future value of option A in year 11? Solve with Excel. Okay, so equals FV. The interest rate is 4.5%, so I'm clicking in that location. NPER is the number of years into the future that this amount needs to be compounded. Skip over the payment field, and minus of the amount goes into the present value section of this equation. So $250,000 now is like having to pay $405,000 11 years in the future. Okay, so I can drag that formula down, and the total that I want to calculate is the total of the future amounts. So equals sum of these future amounts. All right, so the future value of option A is $51,046. And what this represents is, let's say that your uncle had to borrow this money for the initial investment. Like he was going to a bank to get the $250,000 to buy the investment option. If he had to pay the bank 4.5%, then a lot of this $33,000 he's getting each month or each year is going to repay the loan to the bank, both the principal and the interest. So this $51,000 represents the excess over and above the 4.5% that's going to the bank. So this would be how much your uncle gets to keep. It's the future value of his portion of the investment that didn't go to paying off the original loan. So it's, you can think of as the profits, the future value of the profits. Any questions so far with either the cash flow diagram or the future value of option A? Okay, now option B, we know the revenue but not the costs. And so let's put in the revenue amounts. Option B, it says, is $25,000 a year for 11 years. And so that's the $25,000 that repeats all the way through to the end. But we don't know how much he's going to have to pay for this. Let's just put in a guess. Maybe the guess is it costs $100,000. Oop, that's $10,000. One more zero needed. All right, $100,000. All right, let's do the future value function again. Equals FV, our interest rate reference. The number of periods is the alternate time column. Skip over the present the payment, and it's the minus of the present value. Okay, so $100,000 at time 0 is the equivalent of $162,000 at time 11. And then we'll carry this through, and we'll sum it up. Now, what we're going to try and find is how much should your uncle be willing to pay for option B so that this profit is equal to that profit. So right now, the option B profit is too high. It's because your uncle didn't pay enough for the alternative. So our goal is we want to make these two things equal. Okay, so you can manually adjust it. Like, look, we're going to get closer if I type in 120,000. So minus 120,000. If he pays 120,000, then that means the future value of the profits is $51,000. If he pays $150,000, it's getting closer to that. But we can automate the process with GoalSeek by going here to the Data tab, What If Analysis, GoalSeek, and our goal is to set this cell equal to the amount we know, 51046, by changing the purchase price that your uncle was willing to pay. Okay, so just to leave it here on the screen for a moment, we're going to set the sum total of the future value of the amounts to the known 51,046 by changing what's in E5, and that's the amount your uncle's willing to pay. And so when I click OK, it's going to change over and over again, and it's your uncle, if he pays 181,000 for option B, then it has the same overall profitability in the future as option A. So this method basically illustrates how you could know what's the fair purchase price for option B if option A is also available. So these two alternatives have an equivalent profitability if you pay 181,000 for option B. It's 11:50. We're out of time. Let me refresh your memory on these announcements. That you've got until 5 o'clock for the assignment that is due today. Where's the announcement slide? 5 o'clock for homework 5. And then homework 6, which is only 3 problems long, that's going to be due on Wednesday, which is the same day as our test. All right, that's it for today. Hope everybody has a good weekend. Remember, I'll be in my office. If you need help, please stop by.